We will discuss about Y parameter, that means admittance parameter. After discussing the theoretical part of this Y parameter, then we will solve these two problems. Now, this is the two-port network. This is port 1 and this V1 and I1, and this is the port 2 and this is the voltage V2 and I2. Now, if I write this equation of V1 and V2 or I1 and I2 in terms of Y parameter, then it will be this I1 and I2 must be a function of V1 and V2, because this is a admittance parameter. So if I express this I1 in terms of Y parameter, then it will be like this. This is equation 1 and I2 is given by 1 2 1 Y21. This is equation 2. If I express these two equations in terms of matrix form, then it will be like this. This is current matrix and this is Y matrix. This is voltage. So this is the expression in terms of matrix form. Now we will define this 4Y parameter. So how to define this 4Y parameter? Now number 1, this is Y11. To calculate this Y11, you have to make V2 0. So how to make this V2 0? By open short circuited this terminal port 2. So Y1 is given by I1 divided by V1 when V2 is 0. That means the port 2 is short circuited. Okay, this port 2 is short circuited. Now this is called input. This is I1 and V1. This is input terminal, so it is called input driving point admittance. In previous class we have already discussed about Z parameter. So it can be equal to this Z11. It cannot be equal this 1 by Z11, because here I have short circuited this terminal, but to calculate this Z11 we have port 2 is open circuited. So to calculate it Z11 we have open circuited this terminal, but here to calculate Y11 we short circuited this terminal. So this is the difference to calculate Y11 and Z11. That's why this are not related, equals to 1 by Z11. So Y11 not is equals to YZ11. Okay, now number 2, you have to define this Y parameter Y22. 1 2. So Y12 is given by I1 divided by V2 when V1 is 0. Then V1 is 0, that means this port 1 is short circuited. Okay, short circuited, and this is called this is I1 by V1, V2. That means it's called reverse transfer admittance. It is called reverse transfer admittance. Reverse transfer admittance. Now we will define the Y21. So Y21 can be written as I2 divided by V1 when V2 is 0. V2 is 0, that means port 1 is short circuited. And this is called I2 divided by V1. So it is called forward transfer admittance. It's called forward transfer admittance. Now number 4, we have to define this Y22. So to calculate Y22, this V1, that means this port 1 is short circuited. This is port, not port 1, this is port 2. Okay, V2 is 0, that means port 2 is short circuited. Here this is I2 divided by V2 when V1 is 0, that means port 1 is short circuited. Okay, so this is called input driving point admittance. It is called output driving point admittance. This is the 4 Y parameter. In this way you can define it. Now we will draw the equivalent circuit using Y parameter. So using Y parameter we will draw the equivalent circuit. Using Y parameter. This is the two equation. Using these two equation we will draw the equivalent circuit. Here this is V1 and this is V2. So this is input port 1. So this is port 1. The voltage across this port 1 is V1. So it is the current. So current, to calculate current, this must be Y11. This is called Y11. So and this is called I1. So I1 is equals to V1 plus Y11, and there must be a, this is the V2. Say this is a voltage dependent current source. So this is voltage dependent current source. So this is current source and this current is Y12 V2. So this is called voltage dependent current source. This is input terminal. Now this is output terminal. Suppose this is port 2. So port 2 is V2, this is V2, this is plus, this is minus, and this is current I2. In similar way, this must be a Y. This is V2, so it must be Y22. Now there must be a voltage dependent current source. There must be a voltage dependent current source, and this is Y21 V1. Okay, 21 V1. So this is the equivalent circuit using Y parameter. in this way you can draw it using these two equations. Now we will draw the pi circuit using y parameter. What is the equivalent pi network? So equivalent pi network, equivalent pi network. So this is the input, okay, this is the input terminal 1, okay, and this is the suppose output terminal, this is port 2. Now this must be y1 and this is y2 and this is y3. So this look like a pi, that's why it's called pi network. In this pi network, what will be the y parameter? So y parameter y11 can be written as y1 plus y2. y22 can be written as y1 plus y3, and y12 is equals to y21 equals to y1, and it must be a minus. So this is the three formula. Using these three formula you can find out the y parameter of this pi network. Okay, now we will give the condition of reciprocity and the symmetry. So reciprocal network, so for reciprocal network, the condition in y parameter, it must be y12 must be y21. Okay, for symmetrical network, this must be equals y11 must be equals to this y22. This is the two condition. One is for reciprocal network and this is for symmetrical network. This is the basic theoretical need to solve this problem. Okay, now we will solve these two problems. Here you see, this is a pi network. Okay, this is a pi network. I have already discussed here, and what will be the formula already I have shown here. So using the formula of pi network we can calculate the y parameter. So this is y11 is given by y1 plus y2. This is y1 plus y2. This is y1, this is y2, and this is y3, suppose. Okay, so here y1 plus y2, so it can be written, this is in terms of r, so it is 1 by 5 plus 1 by 20. So it can be written as 24 plus 1, so it will be 5 by 20, so it is equal to 1 by 4 mho. Okay, 1 by 4 mho. Now y y22 is given by this and this. So here 1 by 10 plus 1 by 20. So it can be written as this is 20. So 2 plus 1, so equal to 3 by 20 more. And y12 is equal to y21 equals to minus 1 by 20. 1 by 20 more. So using the formula of equivalent pi network, we can calculate this y parameter of this problem number 1. Now you have to solve this problem 2. What is the problem number 2? Using these two formula of the above network, you have to find out this parameter y1, y2 and y3. This is y1, y2 and y3. Okay. So y1, y2 and y3. Here we have taken that this is a y3. So from this equation we can write that the equation for y parameter I1 is given by y11 v1 plus y12 v2 and I2 is given by y21 v1 y22 v2. This is the pair of equation using y parameter, and here I have y11 5 v1 minus v2 and this is I2 is given by minus v1 plus v2. So this is the equation 2. So comparing equation 1 and 2, we get that y11 is given by 5 and y22 is given by 1. Okay, and y12 is equal to minus 1 and y21 is equals to minus 1. So here y12 not is equals to y22, that means it's not symmetrical. This is not a symmetrical network, but this equal y11 12 is equals to y21, that means it can say that it is a reciprocal network. Okay, now you have to find out this y1, y2 and y3. So using the equation of pi network, we can say that y11 is given by y1 plus y3 and is given by 5. So this is 5. So now this is equation number 3, suppose, and y22 is given by y2 plus y3 is given by 1. This is equation number 4. This is equation number 4. And this is y12 is equals to y21 equals to minus y3, that means this is minus 1. This is only 1, minus minus plus the equation 5. So using these three equation, we can solve that the this is y3 is 1. So from this equation we can write that y1 is equal to 5 minus 1 equals to 4, and y2 is, from this equation we can say that y2 is equals to 1 minus this is 1 and this is y2, y1 this means 0, okay, and y3 also 1. So y1 is 4, y2 is 0 and y3 is 1. So this is the problem 2. So in this way you can solve this type of problem using y parameter.